Hi, so we will be testing something interesting today. We will try to create a basic server using one, and then we'll just try to scale it to 1 million requests, and let's see if we can handle or not. So this is a pretty basic file that you see here, and this is what will be running in a VPS, and that VPS would be DigitalOcean. So this is a simple API that I've written. It's nothing much. All we do is just return a response. So one is on and then a random number. That's all that we do here, and it just logs something here when it's running. Now this log is only once, you see, and this is our HTTP server right here. Why did I use one? Because I didn't want to install multiple packages and do all of that, and it just executes it to one single binary. So that is why I did it. To be honest, there's nothing against Node.js. And after doing this, if this comparison becomes really interesting, then I might just try some other languages as well. So without any further ado, let's see what our specs are for this VPS. So I'll be using DigitalOcean as our VPS, and I've already configured it, and the server is on Bangalore 1, and we've got 2 vCPUs, 4 gigs of RAM, and 120 gigs of NVMe SSD, and it's an Intel base processor. Now let's see. So I've already configured a few things here. So we have got our VPS here where the code is running, the one that is our HTTP server, and the other one is, let's just go here. So let me show you. So I wrote a very simple load test using K6, and it will simulate the testing for users. So if I just show you, okay, let me just cd into this file and show you how it looks like. So this is our code. This is pretty simple. What it does is, in stages, for 2 minutes, it will try to run or simulate multiple users. So first 30 seconds, it will try to simulate 100 users, then next 30, 500, and then next 30, 1000. And it will just try to hit this endpoint that we have here, which I showed you in the code, and it will try to see if it passes or not. Now, how would this look like? So let's see. Here's our VPS, which is running our code, the HTTP server. This is what it is. Now, mind you, for this part here, or our VPS, Nginx sits in front of it. So Nginx is our reverse proxy here. Now let me just get this back here and make it pretty simple. So this is our current VPS right here, and this HTTP server that you see is containerized using Docker. So we have got Docker container here, which is running on port 3000 currently. So this is it. Now what it does, so we've got our load tester here, K6, which will try to fire up requests every 30 in the span of 30 seconds. It will try to incrementally keep on firing up requests. So first 30 seconds there would be 500 users, then 1000, and like that. So let's see if it passes or not. And the main important part here that I have done some tweaking is, if I just show you my, where's the command? So yep. So if I just show you my Nginx configuration, you'll see there are worker connections, 800 and almost around 8K, and that is 8192. Now why did I do this? So previously this connection was set to somewhere around 760. By default that is it. Now what are these worker connections that you see here? So Nginx has this concept of workers. So this is something what Nginx has. Let me make this bigger, and each worker, sorry, let me just change this to here and bring it down here. So Nginx has a concept of processes and workers. Now what it does is, so let's say if you've got a CPU which is a 4 core, so it will spawn up at max 4 processes in one core. So while this circle, let me just delete that and copy this one right here. So you'll have 4 such processes. And if I try to bring it in line, so you get the gist of it. So there will be 4 processes in total, and then you've got workers here. Now what are these workers? So every process can spawn up these many number of workers. So 8192 is what I've given here, and so the number of processes here are 4, so it can spawn up 8192. So there will be multiple here, right? So as you can see, there could be multiple. So similarly like this, and so on, it goes on. So, and this process can also spawn up 8000 workers, and similarly it goes on. Now the main important part here is, why did I write the number as 8192? Now you have to see the thing that everything that here you see what Nginx does is bound to by your system resources. So this is very important, that your server, which is here, has limited memory, right? It does not have infinite memory, and it cannot actually handle a lot of load. It's just 4 gigs of RAM that is present there, so it cannot handle a lot exactly, and we'll see why I'm saying that. So why is the case? Because every process that you see, every process and a worker that you see will have some associated memory with it, because the kernel needs to know, right? So when, let's say, we've got something like, so this is our, let's say, client, and we've got our server here. So we've got a client and server here. So if you see, when a client starts making requests, so the client will start to make multiple requests, because there won't be just one client, they'll start to make multiple requests as well. Now you saw, if I just go back to how our system is, you see, if we have got a client here, let's just create a client. So for now, K6 is just a load tester here. Now let's say if you've got a client, now there will be multiple clients who will be interacting to our server, right? So let me just create these 3. So so there are a lot of clients who are trying to connect to our backend. Now you see who's sitting in front of it. Nginx is sitting in front of it and telling, okay, this is the application that it needs to go to, and it will forward that request to that particular application. Now, how does it know that which application to forward to? And those things are there in the HTTP headers, obviously, and Nginx knows from the headers that okay, this is the particular application, and it will forward it to that. But there are a lot of other things. That is, since multiple requests are coming, there comes a concept of a lot of overhead. Now, why this overhead? Because we have connections here now. Now, if you see that multiple users are coming in, we have got a lot of sockets open. Now, if you see all of these connections which are made to the particular users, which is holding to different users, they will have some TCP connection. Now, it will have headers. Now, it will also have some metadata, and it will also hold some data for that particular TCP connection, and that goes for everything which is here. Now, everything is limited to memory here, because if you see that if you've got these many requests here, now let's say another request comes. So, how would the particular server know that okay, it is connecting to this particular backend, and what data it needs, because there are 1,000 other connections which are open, right? So it has to maintain something in the memory to identify and distinguish with each other. So let's say this is one, this is two, this is another TCP connection, and then this is four or something. So there are many, and everything is receiving some bytes. So let's say there's some huge data, as in let's say something like 5 megabytes or something, which is a lot for when you're sending. I mean, it's not a lot, but still it is way larger when you're trying to maintain a million connections, because if you see a million connections and then you've got to establish TCP connection for each particular user, so there's a lot. Now then the memory bandwidth also becomes a lot. So if your, let's say, network cannot handle that much congestion, it will fail. So that is where all of these problems come in. So in order to tackle that, I had increased the worker connections to 800, sorry, my bad, I've been calling it 800. It is 8K, almost 8K, 8,192 now. So what this does is, so each process can handle these many workers, so 8K workers approximately. Let's just call it at 8K. So this is what it. Now, if you see, it is not exactly 8K. There will be less. Why? Because of how Nginx behaves. So a request, when it is coming from a particular client, and it tries to establish a TCP connection, then what happens? The Linux kernel tries to do that, and it tells the backend proxy server that here you go, there's a TCP connection that has been established. So that is done by one particular worker, right? Now another worker has to go in the Docker container and has to find that, okay, where is that particular HTTP endpoint where it's going to process this request. So you see, two workers have been used just for one particular request. So everything decreases by half already. So that is why there's a lot. Now let's go back to this and instead try to run it and actually see what is happening here instead of just yapping out. Now this is the start of it. As you can see, the CPU right now is at 0.5%, and the memory usage is 8.8 megabytes. So we have just got a Docker container running, and inside that a very minimal one application SSH'd into the other droplet. So like I said, so there's one droplet that I created, which is for this particular application, our application, the HTTP server, and there is one more droplet with almost similar configuration, but for load testing. So here is a pretty simple script that I wrote. I'll show you that as well. So this is how it is. First, what it would do is target or create 100 users for first 30 seconds, and then 500 users will try to do it for the next 30, and then 1,000. So how this works is very simple again. So let's say if there are multiple users, 1, 2, 3, let's say there are 3 users right here, they'll try to target my application. Okay, here you go. Okay, it's getting weird. So they'll try to target my application here. So here the users are trying to target my application. Now this is how it works. So one request is gone, second request, third request, and then comes the next request. So this is how it works. So let's just run the load test. So we have started the load test here, and let me just minimize this as well and minimize this, and we'll be able to see how it is working. So here you can see how the tests are going. So it's been first almost 30 seconds, and you can see here the CPU is about 5%. So it's just 500 users now. Now you need to see what's going to happen when it tries to give me more users. So currently it's at 250, and we are still at 5%, and the memory usage is also fine, and there's no problem. So at 100 seconds, at 60 seconds, sorry, we will be bumping up to 1,000 users, I believe, or 500 users. Let's see, what was that? 100, 500, 1,000. Okay, so we'll be bumping it to 500. Okay, so it comes down to 500 users now. As you can see, there is a very huge spike. Almost 5x spike was there because it was 5%, and now it's at 32% CPU. But the RAM usage you see is very low here. It's 10 megabytes only, and then it has dropped. Now it's at a pretty decent CPU usage, and everything's going fine. And we are at 1,000 users now. Okay, at 1 minute. Okay, so it's pretty good now, and everything's being handled. And we'll see what the timings are after this test is done. So I believe the last 30 seconds is for 0 users. So that's what we are. Okay, so we are reaching the 2 minute marks. Okay, so this is done. Now let's come at the main part. As you can see, the CPU has dropped to almost 0.10%. That means the test is done. So coming on to what the results were for the test. So it did pass. Now this is really the thing that we need to see here. That is, we were able to manage to get 1,300 requests per second, and we need to see what the latencies were. So the average was 290, which is, I believe, very I wouldn't say it is very good, but it is obviously way above therein. Anywhere in 200 milliseconds is pretty decent, to be honest. And the minimum was very good, to be honest. And maximum, yeah, you see, it took 3 seconds. That's where the bottleneck started happening. So P90 is 859 and P95 is 1.1 second. So we need to try to reduce these two. That is what we need to do. We need to reduce the P90 and P95 here. And apart from that, I believe it did pretty good, to be honest. So the next part I'll try to see, and we'll try to come up with a way so that this P90 and P95 timings are reduced. And let's see what we can do, what more optimizations can be done to do this. And later on, I might just use some different language as well to try to compare with the same settings on my VPS. Yeah, let me know if you like this, and if you have any questions or if you have any feedback to it, please do let me know. And yeah, thank you for watching.